Problem 16.36. In this problem, an electrical current of 5 amps passes through a resistor and has a measured voltage of 6 volts across the resistor. The resistor is cylindrical with a diameter of 2.5 centimeters and a length of 15 centimeters. The resistor has a uniform temperature of 90 Celsius and the room air has a temperature of 20 Celsius. Assuming the heat transfer by radiation is negligible, we need to determine the heat transfer coefficient by convection. So let's start by simply drawing the resistor. So it says that it's cylindrical, so we're simply going to have a simple cylinder. It says that inside of here there is going to be a certain amount of electrical current and is going to create a voltage which is going to create an electrical power. This electrical power is going to be dissipated using, in this case, only convection. So the amount that we're going to lose is going to be by convection only. Since there is no radiation, the balance of energy makes it that the amount of electrical power is equal to the amount of heat transfer lost by convection. Okay, so let's start with the calculation of the electrical power. Is equal to the amount of the current times the voltage. So that's simply 5 amps times 6 volts. That is equal to 30 watts. The amount of heat rate lost by convection is simply equal to H area Ts minus T infinity. In this case, we're going to assume that the area is equal to the surface area plus the summation of both of the ends of this cylinder. So in this case, we're going to take the total area to be the surface area, which is pi dl, plus the two ends, which are going to be 2 times the cross-sectional area of pi 4 d squared. Okay. In this case, the area is going to give us 1.01276 meters squared. Once again, in this case, we're assuming both the surface area and both of the ends. So we're going to solve. Now that we have these two equal to each other, we're going to simply say that the value of H is equal to the amount of electrical power, the area, Ts minus T infinity. And we're going to substitute the values. So this is 30 watts. The area is 0.01276 meters squared. The surface temperature is 90 and the ambient temperature is 20, and this is Celsius. And we find that the value of H is equal to 33.6, and the units are either watts meters square Celsius, or you could also write it as watts meters square Kelvin. Both of those units are equivalent to each other.